So much like the first 5, I would say, lessons, maybe 6. You guys had some, prerequisite knowledge there. It's kind of a refresher. Maybe not the calculator operations. Some of this probability stuff should sound familiar to you, but it's valuable enough to again, together. I don't know when the last time you would have done a probability. Maybe 8th grade. Or SAT prep. So maybe some of you sooner or more recent than others. So again, this is not on test 1. This is the beginning of the next sort of unit. So I'll also remind you, I said this during lesson 1, I'm not going to ask you on a quiz to define the word event. I might use the word event and expect that you know what it means. No, yeah. So probability experiment is just sort of like an experiment that we do to define the probability of something happening or not happening.
So probably there was some small Friday.
Well, I saw a graphic this weekend, and it was like the United States, and the tops portion of the states were really blue, and it faded to like lighter blue, and then it went to green. And the name of the graphic was amount of snow necessary to cancel school. And in the little legend down at the bottom, that like what each color meant. Like the blue was like 1 to 2 feet. So that's like New England, New York, Minnesota. The green, which Virginia was any.
True.
So I don't know if there's 70% chance that there's snow. I don't know what it is. Is there? It's like 70% chance of mix or whatever. The probability of having a snow day is 70%. According to that graphic. Any snow.
It's 80%.
80%? So you know that predicting the weather is not a exact science. They're using information, just like we would. Yes. All right. So if I were to flip a coin, each thing I did would be a trial. Each time I flipped a coin would be a trial. Head. If it came out to be heads or tails, that would be an outcome. The sample space is all the possible outcomes. So if I want to flip 3 coins, combinations of flipping 3 coins creates my sample space. And then an event is a way that those things happen together. So if I flip 3 coins, I get a heads, and a tails, that's an event. It's one possible outcome. So I don't know that you need to write this. You might write flip coin, roll die.
Or just right now.
Huh? Or just write nothing. I mean.
Is it about a test?
Yes.
Oh,
In that case.
Take a test. I don't say much that's not on the test.
well, you said this right flip. I'm not gonna understand if I right flip.
So if we want to create the sample space or identify the sample space, one way we can do that is by first creating a tree diagram. And then we'll list the sample space in curly brackets because a sample space is a set of all possible outcomes. So if I flip a coin, I can get either heads, or I can get tails. So I'm flipping a coin and then I'm rolling a six-sided die. My possibilities, if I flip a heads and then roll the die, are getting a heads and a 1, a 2, 3, 4, 5, or 6. If I flip a coin and get a tails and then roll the die, I still have the possibility of getting a 1, 2, 3, 4, 5, or 6. So this is my tree diagram. If I want to list the sample space, I list all the possible outcomes of flipping a coin and rolling it up. So I can get a heads and a 1, a heads and a 2, heads and a 3, so on.
Can we just do 6 times?
Can't you just do 6 times what? 6 times 2 will tell you the number of outcomes. But if you want to know all of the possible outcomes, you actually list them.
So that's why I asked you to actually list out all the
Yeah, if I say write the sample space, don't tell me how many things are in there. Actually write it. This is the tree diagram. This is the sample space. These are all the possible ways of flipping a coin and rolling a die. Yes, there are 12 of them. There are a couple in the practice that get a little absurd because there's a large number of possibilities. I'm not going to do that to you on a quiz or a test. That's not the...
So you're going to ask how many outcomes there are, or
Yeah, I might ask you how many outcomes there
you're
are.
not going to describe it?
This won't probably be... No, I'll tell you this. I'm not going to write a test question or a quiz question about this. So, but it is worth bringing up. If there's only one way something can happen, we'll consider that a simple event. If there's more than one way something can happen, we'll not consider that a simple event. So there's only one way to throw heads and roll a 3. You have to flip the coin, get heads, roll the die, get 3. Only one way. If I flip the coin and get tails, and then I roll the die and I get an odd number, well, there's 3 ways to do that. I can get tails and a 1, tails and a 3, tails and a 5. So that would not be a simple event. So I want you to try those few problems. I will give you 5 minutes. So Some of you have already alluded to the fundamental counting principle. Let me give it a name. It's the fundamental counting principle. So I think Aaliyah said, can I just say 12? When I flip the coin and roll the die, there are 12 possible outcomes. That's the number of outcomes possible for flipping a coin times the number of possible outcomes for rolling a die, times 6. So if I want to do things in succession, flip a coin 5 times. I just multiply the possible outcomes for each coin flip, and that'll give me the number of total possible outcomes. This is the going in your closet and picking out a shirt or a pair of pants and socks. I think you might have done. Is that an SAT style question?
Yes. There was a question like this.
So maybe the question should, or maybe the statement should be, I have nothing to wear. It should be, I have too much to wear. There are too many options.
In high school, the objective was like to everybody pass, but like in college, they make the courses so that like you they're combined to fail.
I'm not sure I college was not.
Why are they like so much like?
The difference is that in high school and stuff, there's compulsory things that you have to go, and in order for schools to get money and part of that, like college, so you don't want to be in sales. They don't. It's your job to work on it. Your job. All right, so let's do an example. We're buying a new car. I think your design might be getting confused with like college classes. So I have 3 possible manufacturers. I have 2 possible car sizes and 4 possible colors. So the fundamental counting principle tells me in order to figure out the number of combinations, I just multiply the number of possibilities for each. So given that criteria, I have 24 different ways to pick a manufacturer, car size, and color. And then we can confirm that by drawing a tree diagram. So I might buy a Ford, GM, or a Honda. After I pick the manufacturer, I gotta pick the size, so I might buy a compact or a mid-size. And then for each size, I would choose a color. So I would either choose white, red, black, or green, white, red, black, or green. I'm going to run out of space. White, red, black, green. So one of the possibilities is buying a Ford compact that's white. If I count along the bottom here, I'll figure out all the possibilities. There's 4, 8, 12, 16, 20, 24. So if I ask for the tree diagram, I'm looking for something like that. If I ask for the sample space, I'd be looking for the list of actual combinations. So 24 combinations of car size, and color. If I just want to know the number, I could just do the multiplication up there really quickly and get 24. There's 24 possibilities. I want you to try this guy on your own, using the fundamental counting. Listen, in scenario number 1, each digit can be used only once, not repeated. So it's a 4-digit code. 4-digit code. So for the first digit, I have 10 options. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever number I use there can't be used for the next one. I have 9 options, 8 options, 7 options. Multiply them all together.
5,040.
5,040. Is it? Yeah. Not necessary. Just multiply them together. If the digit can be repeated, there are 10 options for each. And then the last one. Each digit can be repeated, but the first digit cannot be 0 or 1. So how many options for the first number?
8.
8. And then 10, 10, 10. So it is
8,000.
The question. So you know how in your iPhone or maybe your Android, the pin numbers, how many numbers? 4. And if you have a bank card, your pin number is usually how many numbers? 4. And how many options for each number are there? 10. So if I were trying to crack into somebody's iPhone, there are 10,000 combinations I need to try. How many chances before that thing just implodes?
Or
There's four chances before it like
Yeah.
self-destructs.
No, before.
So
like locks you out for like 10 years.
it's very unlikely that you get somebody before the phone locks.
Unless it isn't for like 1111.
That is a possibility. All right.
I know, remember, and I just we got minor.